So here's what we're doing today. We are learning to factor, and we are factoring in the form where a is not equal to 1. Meaning, remember where I said x squared plus bx plus c. And x squared plus bx plus c, you just did a whole sheet of them. There was no coefficient in front of x. You just said which two numbers multiply to give you this, but add to give you this, and then, right? So when there is a coefficient in front, all rules change. Remember that nice little, oh, what did you multiply to this to get that? You can't use that anymore. We're going to use a version of it. But when there is a coefficient in front, it's a little more involved than that, okay? So in order for us to factor these problems today, you would think adding one little number, meaning in other words, instead of factoring 2x squared minus 7x or minus 15, just x squared, that 2 is going to be there and it's a game changer. So let's talk about that. There are two things we need to know and kind of review ahead of time. And one of them is going to start with that blue sheet. So go ahead and get puzzle set number 1 out. And we did a version of this in our heads, but today we're going to do something called the X box method. Sounds funny, but we're using an X and a box, so they call it the X box method to factor. So I want you familiar with this X and what it means, okay? And like I said, we've done this already. So if you look, the top number is your product, and the bottom number is going to be your sum. So you did the version of this in your head. What two numbers do you multiply to get 4 and add to get 4? 2 and 2. Okay, so we started off pretty easy. Let's do number 6. Let's do another positive one. So what two numbers do you multiply to get 6, but add to get negative 5? So remember, when your product is positive, the only thing you know is that both signs are the same, right? You could have a negative and a negative or a negative and a positive, but your sum is negative. So you know both of these have to be negative, right? Okay? So we're going to put that one negative and that one negative. And then, because that's a plus, we add. So obviously this is, what are we at? 2 and 3. Okay? And here's how you check. This times this should equal that. This plus this should equal that. Good? Okay, so let's do number 9, the next positive one. So positive product with a positive sum means that you have a positive times a positive, which you don't need to put if it's positives. And then, obviously, this is going to be what? 3 and 4. Okay? So then, let's go back up to number 3. When your product is negative, remember what I said that means? The only way to get a negative product is a positive times a negative. And then, I'm not adding them to get 13. I'm subtracting. So you would think 10 and 3, but I have to add them, or subtract them rather. So I'm going to use what? 15 and 2? Okay? And then that negative 13 means that I want my sum to be negative. So I'm going to take the bigger number and put it with whatever sign I want it to be. Okay? So this is kind of just a written version of what you guys did in your head this weekend, right? So let's just do number 5. A negative product means a positive times a negative. And then I want them to multiply to 24, but subtract to 5, 8, and 3, right? So then the 5 is negative, which means I want the 8 to be here and the 3 to be there, okay? So are we okay with that? So the part of this method involves the x. So we are good with that. So this one, you would think 25 times 3 is the most common one, but that doesn't work. So 15 times 5. So we have a positive and a negative. That needs to be negative, so we have 15 times 5. Okay? Good with that? So I copied the whole back sheet too. You don't really need it to go with it. I just wanted you to kind of get familiar with that box. And it's really important to know that the product is the top and the sum is the bottom. Okay? All right. So that was prerequisite number 1. Prerequisite number 2 is finding the GCF of polynomials. Okay? So maybe I do need a little bit of notes here. So we know how to find the GCF of regular numbers. So like if I were to ask you to find the GCF of 8 and 14, okay? When you were in, I don't know, 4th grade, 3rd grade, when you learned about factors, your teacher probably had you write a list of all the numbers that go into 8, right? Then they had you write a list of all the numbers that go into 14. And then sometimes they had you get a different color, right? And then they said, find the greatest common factor. Yeah, I know 1 is the greatest common factor of every set, but 2 is the biggest one, right? Okay, so 2 is the GCF of 8 and 14. And that's also what you would use to find a common denominator or to reduce, right? So this obviously would just be 4/7. And so GCFs come in handy a lot. What you haven't talked about yet is if I were to ask you to find the GCF of x to the 2nd and x to the 3rd. Okay? And so if we kind of apply that same thinking of, okay, let's list out all the factors of x to the 2nd and x to the 3rd. Well, I got x to the 2nd by doing an x times an x, and an x to the 3rd by x times x times x. And what the greatest common factor is, what is the biggest amount that you can get from both numbers? You have to get the same amount. That's why the word common is there. So I can get an x from both of them. I can get 2 x's from both of them, right? So I can get an x squared. Can I get more than 2 out of this one, though? No. So the GCF of x to the 2nd and x to the 3rd is x to the 2nd. Because it's the most I can get. If you have to have the most from both, isn't it from the least? Right? Does that make sense? So if I were to ask you to find the GCF of a to the 5th and a to the 7th, my GCF would be what? A to the 5th. Because I have to get the same amount from both. I have to get the most from both. So I have to get the most from the least one, the smallest exponent. Okay, pretty easy? So if I put those two together and say, okay, find the GCF of 12a to the 3rd and 20a to the 5th, the GCF, we combine it. We would do the number and the exponent part of it. So what is the GCF of 12 and 20? 4. And the GCF of a to the 3rd and a to the 5th? A to the 3rd. So the biggest I could pull out of both is a 4 and an a to the 3rd, right? So how about, let's say 18x and, let's say 18x squared and 24x. So what would the GCF of both of those be? 2 goes into both. 3 goes into both. 6 goes into both. So 6 is the biggest. And then, that's going to put equals. And then x, right? Because you can only get one out of both. Okay, so those were my 2 prerequisites. Now we're going to talk about the x box. So we know how to do the x. We know how to find a GCF. So let's do our x box now. Okay, so that's your second sheet of paper. So go ahead and get that out, the white one that I gave you. And there are actually going to be 2 methods that I show you. 2 methods. Okay? Method 1, we're going to call the X box. And a plus of doing the X box is if you do it right, there's no guessing. You will get it right every single time. It is a surefire way to get the correct factors. Okay? The second method is good old trial and error. And we can't discount trial and error because sometimes it comes in pretty handy. Okay? Trial and error means I'm just going to kind of pick 2 numbers and see if they work. I'm going to multiply it out, and if it works, great. If it doesn't, then I got to go back and try another combination, right? The good part about trial and error is, have you ever done something that you thought was going to take forever on like the very first try? And you're like, oh my gosh, that's awesome. I got it on the very first try. And if that happens in trial and error, then you just saved yourself a lot of time. Because the Xbox method could be a little time consuming once you're starting. Once you get the hang of it, then you get going. So could take long, and I'm gonna give you examples where it might. I'll show you. Let's just get going on the Xbox first. So again, I like to give you options, right? Remember when I asked you to do a plus 3 to a minus 4, and I said, hey guys, you can double distribute it, or you could box it out if you want. Remember I gave you an option? So you have options today. I'm going to show you both. My guesses are, for those of you who did the Xbox, or for those of you who boxed it out, you're going to like the Xbox because you're still working with that box. For those of you who did the double distribute, trial and error goes with double and distribute. So they kind of go together. So let's get to what this Xbox crazy thing looks like. First of all, you're missing your X. So go ahead and write an X in right here for me. It's on the back side. Okay, so the first trinomial we're going to factor is 2x squared minus 7x minus 15. Okay? All right, and you remember how I told you that your when you factor this, it's ax squared plus bx plus c. So a is the number in front of your x squared term, b is the number in front of your x term, and c is just your constant. So the first step, so I guess we can do this. Let's say it's step 1. Identify your a, b, and c. So a is 2. B is, be careful, you know by now, that's not just a 7. That is a negative 7, and C is a negative 15, right? Okay? So step 1 is done. I just identified them. Step 2 is going to be to fill out your X box. Now, here's the deal with this, though. All the ones I gave you before already had the product and the sum there. You're starting with a plain old blank X. Okay, so here's what you have to know. That you are going to put in A times C here, and your B term is going to go there. You'll start to remember this. So your A times C goes here, and your B term goes there. So you know that that's going to just be negative 7, because that's my B. And then what is A times C? A times C is negative 30, so that goes there. Okay, so that's step 1. Identify A, B, and C. Step 2, fill out your X box. Okay, step 3, I'll put a little 3 here, so you know the next thing you're going to do is fill these two numbers in. And this is the note, so they're telling you, take your whole ax squared term and put it here. Take your constant and put it here. That's step 3. Following me? Okay. Step 4 then, I guess we could have probably made this the step 4 here. We should have filled this out. So we can fill this box out right now. So find these two numbers. We should have just made that 3. That's kind of frustrating that I missed that around. So I'm looking for two numbers that when I multiply them, I get negative 30. But when I, we could do this. 2 would just be fill out your whole, the whole thing. So negative 30 is a positive times a negative. What two numbers are going to give me 7 then? What's that going to give me? 3 times 10 and 10 minus 3, right? I need that to be a negative. So this negative has to go 10 and 3. Okay? So then the next step is going to be to take these two and put them here. Okay, but watch. There's a little trick to this. You have 2 numbers and you have 2 blanks, right? So you're going to put, and it doesn't matter where you put one. I'm just going to put the negative 10 here and the 3 there. Okay, for notes purposes, you'll probably want to go with me and put them in the same spot. But the next one you do on your own, could they be mixed up? Sure. Okay. Now, here's the other thing. So stop for a second, and let's go look back when we boxed something out. because something's missing in that box. If I had a 2x minus 8 and a 3x plus 1, okay? I just want to show you we're undoing the box. How many of you did the box method when you did it? Okay? When you multiplied them, didn't you do these two, and that's what made your x squared term? Right? And then you did your 2x times your 1, and that was a 2x. A negative 8 and a 3 was a negative 24x. And then your constant was always here. So what do you notice that this box and this box contains? Your x's. So I have to remember to put that x in those two diagonal boxes or your problem's not going to work. Okay, so you have to remember to do that. So I have everything, and you know what I want you to put in this box? In your head. You don't need this box. What this box is for, it's having you list all the factors of A and C, meaning 1 times 30, 2 times 15, 3 times 10, 5 times 6. So what I would probably do for next year is erase this box and put an X there, but so you didn't really need it. All right, I have everything I need to finally factor this. I identified my A, B, and C. I used them to make my box, my X. I used my X to find my factors, and now the real work begins. So I want you to put in the corner right here and right here that I want these two boxes to always stay positive. And here's the reason why. When I asked you to multiply numbers out, you never saw a 2x plus 8, did you? That was never a negative. Okay, and there's going to be a reason for that. You can't have a negative x squared term. So these terms both need to be positive. So watch. This is actually really cool. So this box and this box are done first. Once you find these two boxes, the rest is easy street. So to find what goes in those two boxes, watch. I'm going to find the GCF of the row across. Remember how I showed you the GCF? What is the GCF of 2x squared and 10x? Now, we're ignoring the negative because I want it positive. So what number can I pull out of both 2x squared and negative 10x? A 2 and an x, right? Now let's pull, what can I pull out of this row, this column right here? Just an x. Those two are my x terms, right? Because look, when I use the box method, that's what gave me my x squared term, good? Okay, so now I could do the GCF of this column and put it here, and this row and put it here, but I found last year that was so confusing to kids because they're like, well, how do I know? Do I pull a negative out or not? So watch, the perfect solution is using the box method. For those of you who did the box method, didn't you multiply this box times this box to get that box? Remember when I said those of you who are using it, you're going to like it later, because what needs to go here that when I multiply it by a 2x, I get a negative 10x? A negative 5. What needs to go here that when I multiply it by an x, I get a 3x? 3. And you have your factors. An x minus 5 and a 2x plus 3. Without fail, every time, no guessing, no checking, because if I did it that way, then I'll get that answer, okay? That obviously took a long time because I was explaining things as I went. Let's do another one and kind of see how it could go quick together. So I have 6x squared minus 23x plus 7. Okay. Let's identify our A, B, and C. A is 6, B is negative 23, C is 7. Draw your X. You do not need to write this here, but for right now it may be a little helpful. I was going to put so A, C, and B. So A times C is what? 42, so that goes here. And this negative 23 goes here. So now I'm looking for the two numbers that when I multiply them I get 42, but when I add them I get 23. It's not your traditional 6 and 7. Cut 42 in half, and what do you get? 2 and 21, right? Because that's positive, but my sum is negative, right? Doesn't matter which one goes where. I just kind of used this box, and I just did that in my head, so you don't need that box. Now I fill in my ax squared and my c. Then I do what? These two go here. Put them wherever you want. I'm just going to do that here and that there, because you'll get the same answer. Your factors will just be flip-flopped around. Okay? So now I identify these two first by pulling out the GCF. And maybe in your notes you want to write, this is the GCF. Okay? So the GCF of 6x squared and 2x is 2x, right? Don't worry about negatives when you do this. What is the GCF of 6x squared and 21x? 3 and an x. Both of these should have your x's in them, right? And now I switch gears and I don't do GCF anymore. I go backwards. I say to myself, if this box times this box needs to be that box, then what do I need to multiply a 2x by to get it to be a negative 2x? A negative 1. And what does a 21x and a 7 have in common? Or actually, never mind, I just totally went the other way. What would I need to multiply this by to get that? So 3x times what is 21x? Negative 7. Sometimes you can pull out the factoring. All right, so now I have 3x minus 1 and 2x minus 7. Got it? Okay, that is the x box. So let's do this. Go ahead and flip it. It's got to be upside down though. You want the line above it. So make sure, so I copied it wrong. So make sure the line is above it. And I'm going to just let you try this one on your own. Let's see, what are the two that we did? All right. Give me a minute to try and get you one to do. All right, to try this one. Are you ready? 3n squared. Minus 17n plus 10. So go ahead and try that one on your own, and we'll do the trial and error. Yeah. It's one Xbox game they don't like to play.
Oh, boy. Well, you know, it's got to be, 5 or 2, 3 and 1? Just got to trial and error. That's all it is.
No trial and error when you have Xbox, right?
You can't do trial and error?
They can, but this method is way better. We're talking about the difference.
Well, we know the sign's got to be the same, right?
Yeah.
All right. The sign's got to both be negative.
Yeah.
That narrows it down.
Mm-hmm.
Right, Paul? All right, here's the 7th grade and 6th graders since you administered this.
Okay,
I don't
perfect.
have those tests.
I do right here. I was just going to show them.
I got the 8th grade ones
Get your
done.
Kleenex
so
ready.
Bill's doing the 6th.
Yeah.
6th grade. He's been talking about,
I know.
because I got a couple, I have
Right
4. I
Under.
got 4, 5. Under.
70.
No. I got 6 that got 70 or above.
Okay.
So I figure they're in.
Yeah.
But the ones that got
68.
right.
That's a cutoff. We have to stick by that. Otherwise, we have no.
I can understand and I do understand that as well. However, what are they gaining out of out of staying.
Then what 1 percentage point? We have to stick with it. Andy's not going to go for it.
No, you don't think so?
No, he said, where are we going to stop? We have to stop at some point.
I think if they got like 1 or 2 extra.
So, okay, this is the difference between checking the tests. Like Seville said, he counted it if they wrote is less than instead of put the symbol.
I didn't.
You didn't. So then, there you go. Boom. There's your point.
Yeah.
If it's one thing they can fix, you know what I mean? Then change. Make their scores then.
Because the one kid, he got like the only thing he didn't put, he didn't know how to write an inequality.
Right. Well, that's easily fixable.
Right, because he's going to get it in 7th grade. It wasn't like he didn't know how to add.
If that's the case, then yes.
That's what I think.
Then but his score is a 70 or higher.
Correct.
You know what I mean?
Correct.
It has to be.
Absolutely.
Has to be.
Absolutely.
Yes. Okay. Good. Same page.
You get this?
Yes. Xbox method is awesome, isn't it?
How do you do the Xbox method?
Okay. So this is your A times your C, which is what? This is your B. Your A term goes here. Your constant goes there. 2 numbers that when you multiply them, you get 30, but when you add them, you get -5, -15, -2. Okay. And then what? Pull out your GCF of this. Yeah. Your GCF of this is what?
15.
Yeah. Your GCF of this is n. 3n times what is -15n? N times what is -2? I know. So did you get 3n minus 2, n minus 5? Ta-da!
That's pretty good.
Yeah, it's
I've never done it that way.
yeah, they like doing it that way.
They
That's
do?
good.